Before the name Orion echoed through star maps and science books, it drifted through oral memory, etched not with numbers, but with awe. Long before telescopes, shepherds and hunters looked skyward and noticed something strange. Beneath the trio of stars that formed the hunter's belt, there was a faint haze, a soft blur in the night sky. Some cultures called it a wound in the heavens, others a sleeping eye. What no one knew then was that they were staring into the closest stellar nursery to Earth, a cosmic cradle where stars are born, shaped, and flung into the galaxy. The Orion Nebula, located 1,344 light-years away, yet visible even to the unaided eye, it sat there, humming gently in the darkness, waiting. As glass lenses gave way to mirrored telescopes, humanity peered closer. In the 1600s, Galileo saw its faint glow and moved on, but Charles Messier catalogued it as M42, a messy patch in the sky he wanted to avoid confusing for comets. It wasn't until photography entered astronomy that the nebula began to reveal its true identity. Layer after layer of gas, vortices of plasma, shock waves rippling through hydrogen clouds. What had once been myth was now movement. But even through the newest optics, the Orion Nebula never stays still. Its light changes, not because it flickers, but because it breathes. The stars being born inside it stir the dust around them, heating and shaping it with radiation. Some grow massive, some die before they ever shine. Every particle inside it dances between creation and collapse, and Earth, by cosmic luck, happens to sit near enough to watch it all unfold like time-lapse photography. If you wait long enough, inside its glowing cloud lies the trapezium cluster, young, hot stars that burn so violently they push their own nursery apart. They carve tunnels in the dust with ultraviolet fire. Astronomers studying these structures often describe them not like scientists, but like poets. They call the filaments pillars, the arcs wings, the dark pockets ghost zones. One researcher once said, "It's not just a nursery, it's a canvas, painted by light, erased by gravity, and painted again." But even as we marvel at its artistry, something deeper lurks in the Orion Nebula's light. Embedded in its glow are silent records of physics that defy expectation. The way it organizes chaos, the speed at which certain stars emerge, and most mysteriously, the shape of the cavity at its heart. The cavity is vast, dozens of light-years wide, a hollow space surrounded by gas, with edges that ripple like frozen waves. It is there, in that silence, that light from newborn stars bounces, bends, and breaks into color. And in doing so, it carries messages, not in language, but in pattern. Each wavelength is a record, each shadow a reminder. To see the Orion Nebula is to see both birth and erosion, creation and entropy, a beginning that is always halfway to its end. Even today, backyard photographers capture the nebula with nothing more than DSLRs and patience. They stack images over hours, aligning them against the spin of Earth. And slowly, the same glow once seen by shepherds reappears, only now in pinks and blues and purples, revealing a universe that speaks through gradients. And in those images, something remarkable happens. The nebula doesn't just appear clearer, it appears closer, like a memory returning. Astronomers once thought they understood stellar evolution. A star is born in dust, burns in heat, and dies in silence, or sometimes in explosion. The rules were simple, if vast, but inside the Orion Nebula, those rules start to blur. The deeper researchers looked, the more anomalies they found. Some stars were far too massive for their age. Others spun with rotational speeds that should tear them apart. And some, perhaps the most troubling, didn't seem to belong to any known sequence of evolution. They weren't dying. They weren't growing. They were lingering, holding their shape in defiance of both mass and time. One such cluster, designated with a temporary catalog name, appears to be made of ultra-dense stars whose heat signatures suggest a life cycle mismatch. They radiate the light of youth, but carry the gravitational behavior of collapsed objects. They shouldn't be there, and yet they are, fixed in the cosmic mural like brushstrokes that contradict the painting's style. Theories poured in. Some believed nearby collisions triggered premature fusion. Others whispered about binary systems interacting in hidden ways. But every answer only led to more unanswerable questions, especially about the odd alignments. Several of these stars fall into nearly perfect lines, spanning light years across, but not random. Their arrangement mimics sacred geometries once carved into human stone. Hexagonal alignments, spiral proportions, golden ratios. Scientists laughed nervously, calling it coincidence. But the resemblance was uncanny enough to spark quiet meetings in closed rooms. One team ran simulations backward, tracing the trajectories of these stars through galactic time. The result? If one rewound cosmic motion far enough, these anomalous stars converged into a single point. A place where no matter should have existed. A gravitational ghost. And then came the archival flares. Old data logs from the Hubble and Spitzer telescopes were reanalyzed with new software. Hidden in background noise were flashes, millisecond events that had never been cataloged. Not from stars, not from comets, but bursts of structured brightness, spaced like a code. Almost like a signal too fast for human reaction, but too ordered for randomness. And they all came from one region, the dark middle where these strange stars sit. To the naked eye, it's just black space, a blot between the glowing filaments. But in ultraviolet imaging, it pulses, a soft heartbeat, irregular, persistent. Some called it a failed star, others, a rogue black hole gently grazing the cloud. But one theory, published and then quietly withdrawn, labeled it something else. An information nexus. A place where stellar patterns were not just natural, but purposeful. Not in the conscious sense, but in the way ants shape colonies or neurons form thought. Emergent, non-linear, alive, in a way we don't yet recognize. One researcher tried mapping the positions of the anomaly stars across a multi-axis fold and found the shapes mirrored acoustic signatures, tones, not images. He overlaid the data on a spectrum, filtered it through an audio synth, and hit play. What emerged was not music. It was vibration, not made by us, not for us. Something very old was pulsing inside the Orion Nebula. And the stars that shouldn't exist might not be errors but expressions, written not in light but in intention. We are used to thinking of nebulae as clouds, as cradles, as accidents of dust and fire. But maybe some aren't. Maybe some are memories. The dust in the Orion Nebula is not silent. It swirls in veils and ripples, like thoughts folding through a mind too vast to comprehend. To most telescopes, this dust is an obstacle, a haze that obscures the newborn stars behind it. But to certain instruments, tuned to infrared and submillimeter wavelengths, it becomes something else. A storyteller, a keeper of echoes, a witness to everything that has passed through this nursery of stars. Within the densest pockets of the nebula, called Bok globules, matter collapses inward slowly under gravity's patient hand. But something about these particular globules has defied expectation. Their shapes are not random. They seem aligned, parallel in strange ways, as though cast by an unseen lattice. One satellite image, taken by accident during a calibration routine, reveals a filament pattern, intersecting lines of dust that form a near-perfect spiral when colorized and layered over time-lapse data. No one claims the pattern is artificial, but no one dismisses it either, because the dust doesn't just sit, it reacts. In one experiment, As astronomers mapped photons scatter across the nebula, they noticed the signal strength would dip, only slightly, whenever certain observation frequencies were repeated, as if the dust was absorbing intention, not just energy. That's when someone jokingly called it responsive dust. The joke faded quickly, because the next time that same frequency sweep was run, a spike occurred, a flare in one of the outer clouds. It mirrored the observational pattern, but inverted. Dust is not conscious. It is not alive. And yet, the readings suggested a kind of feedback, a dialogue. Not intelligent perhaps, but aware, in the way a sensor might be aware of touch, or a memory of heat lingers in metal. This dust, ancient and unbound, stretches across parsecs. It is made of the crushed bones of stars and the molecular fingerprints of planets never born. Every speck contains carbon, oxygen, silicon, building blocks of both life and extinction. And it has watched, for millions of years, it has watched as stars flared and died, as solar winds carved voids into its body, as comets slashed through its ribs like needles through silk. A strange event occurred in 2012, when a radio telescope array picked up a sudden burst from the Orion complex. Not a fast radio burst, something subtler. It was a tone, not musical, but evenly spaced, perfectly timed pulses like sonar, directed not outward, but inward, as though the dust was mapping itself, sending echoes into its own folds, seeking something. That same year, a graduate student noticed that when you overlay the tone's frequency pattern over the Hubble imagery of the nebula, certain gaps, seemingly empty zones of space, match perfectly with nodes in the signal. Zones previously dismissed as unremarkable. Now they shimmer with implication. Perhaps these were not gaps at all. Perhaps they were eyes. In the years since, attempts to replicate the signal have failed. But some astronomers claim the dust moves differently when studied too closely, that instruments malfunction in subtle, untraceable ways. That data begins to loop. A pattern emerges, but then unravels. Some swear their own models change themselves overnight, as though overwritten not by error, but intention. Of course, none of this is conclusive. The nebula is chaotic. The universe is random. Dust obeys physics, not feeling. And yet, no one looks at it quite the same now. A hesitation has crept in. Not fear, exactly. Something quieter. Like the pause before knocking on a door you're no longer sure you should open. Because in Orion, the dust does not simply reflect. It seems to remember, and some of it is facing us. Deeper within the Orion Nebula, beyond the reach of the most sensitive telescopes, there is a region no light has escaped in decades. Not because it is dense, but because it forgets to shine. They call it LDN 1641, a dark tendril of gas and dust that appears to trail off from the bright trapezium cluster. It's not empty, it's pregnant with potential. Protostars lie coiled in its veins like ideas yet to be thought. Astronomers had long assumed this region was simply quiet, too cold, too shielded to yield light. But something changed during a deep exposure run from the James Webb Space Telescope. The telescope was not meant to stare so long, but a software glitch locked it in place for 73 minutes. And when the data returned, the results didn't just show forming stars. They showed sequence. In 3 different cores within LDN 1641, young stellar objects were caught at nearly identical stages of formation. Spiraling disks, jets of molecular hydrogen, infall zones, all matched to within a margin so precise, it resembled symmetry, not chaos. Stars should not synchronize. Gravity is not a metronome. And yet, these protostars behaved as if choreographed. And then came the image. It was just a streak at first, redshifted and blurred, but it ran between the 3 objects like a thread. Some dismissed it as a cosmic ray artifact. Others enhanced it, ran it through filters, removed the noise. What they found looked like a helix, twisting, branching, anchoring the stars like neurons in a nervous system. Some papers called it coincidence. Others didn't publish at all. But word spread. Not through media, through encrypted networks of astronomers and data analysts, quietly cross-referencing star nurseries across different nebulae. The same helix had appeared, fainter, rotated, decayed, but always connecting stellar births with uncanny precision. The idea took root. That memory was not just a biological concept, that perhaps, in the universe, memory could exist in the alignment of matter itself. That dust and gravity and light might form not only stars, but recollections. What if the Orion Nebula was not just birthing stars? What if it was rehearsing? Some theorized a kind of cosmic imprint, like a galactic scar, where the deaths of old stars influence the shapes of new ones. Others whispered stranger thoughts, that the dust carried impressions, like grooves in a vinyl record, waiting to be played again through gravitational resonance. A pattern, a code, a replay. And what if we were part of it? One researcher, unable to sleep, layered centuries of Orion depictions, from Babylonian tablets to Mayan star maps to Renaissance sketches. He expected inconsistency. Instead, he found echoes, same curves, same cluster ratios. Artists and shamans and astronomers across time tracing the same outline. He posted the composite online for just an hour, then removed it. But the file lingers in corners of the internet, shared like a riddle no one admits believing. Some say the nebula is watching us, but perhaps it is simpler than that. Perhaps the Orion Nebula is remembering us, not individually, not personally, but as a shape, a frequency, a recurring motif in the dream of the cosmos. And as our instruments grow sharper, as we peer deeper, we begin to suspect, maybe the universe is not expanding into emptiness. Maybe it's echoing something it already knew. And Orion? It's the voice that never stopped singing.